How and where are we going to write our GLSL code? So, an environment was set up for us by Patricio. There's a link in the description. Go there now. The code that you see, just delete that and then copy and paste the code down below. Also, drag the canvas over to the left a bit so we can see the whole thing. And so this is where we're going to write and we're going to run, or our code's going to render from. This environment has done a few things for us. It's created a canvas as well as some global and constant variables. Let's tackle this canvas first. What is this canvas? In the previous video, if you haven't seen the previous video, there's a link in the description. Go watch it. I talked about two different types of shaders. I talked about fragment shaders and I talked about vertex shaders. I told you that fragment or pixel shaders, that they rasterized or colored in objects. Objects created by vertex shaders. And so our canvas is actually an object created by a vertex shader. What this vertex shader did was it drew two triangles. We'll go 4x4 here. Two triangles, and it treated them as one solid rectangle or one square canvas. All we see, of course, is this smooth surface, no diagonal line there. Now what we're going to do with the canvas is we're going to treat it as though it's on a Cartesian coordinate plane, or an X and Y, a two-dimensional plane you learned about in Algebra 1 or I think pre-algebra class. So we have our X-axes and we have our Y-axes. So the bottom left of our canvas is going to be 0, 0. The bottom right is going to be our 1, 0. The top right is our 1, 1. And the top left is our 0, 1. All we have to do with our fragment shader is tell the GPU what color each pixel is. So our vertex shader sets us up, and then we knock it all down with our fragment shader. What color is each pixel? So go back to the code we pasted and let's break it down. What are these first lines saying? Or rather, what are we telling the editor or the environment? Well, these first three lines of code are setting a default precision level for our floating point numbers or variables. What does that mean? Well, in programming, there are different data types. There are strings, there are arrays, objects, hash maps, dictionaries, and there are numbers. There are different types of numbers. The numbers are typed by how precise they are. Basically, how many numbers to the right of the decimal point are they? How accurate are the numbers? Now, more accurate numbers mean more accurate calculations of color and movement, but at the cost of speed. But since all we're doing is rendering simple colors to the page, to the screen, we don't need super accurate numbers. And so we set our default precision level to a medium floating point. Now these next three lines of code declare a function. All of our fragment shaders need this function. GLSL is a C mimicking language, so what this says is that we want a function called main that returns nothing or void. Now even though our function returns nothing, it must set this GL frag color variable, it's a global variable, to a vector of 4 elements. This is our way of telling the GPU what color each pixel should be rendered at. If you don't know what a vector is, it's basically a set of numbers that point to a place in space. In the previous video, I talked about linear algebra and how it was the strain of mathematics that allowed us to manipulate points and lines and planes in space. We don't always need to think about it like that. What we're doing with this GL frag color line is we're taking advantage of the syntax or the structure of a vector to kind of package up 4 numbers and move them around as one unit into frag color. So it's just a convenient way of packaging up numbers, and GL frag color expects a vector of 4 elements, not a vector of 3 or 2 or 5, a vector of 4 elements. These elements, of course, have meaning. They're not just random numbers. The first number is your red value, the second is your green, the third is your blue, and the fourth, of course, is your alpha, or your transparency or opacity. And so let's go ahead and change the first, the third, and the fourth number to 1 and see what we get. So 1, 0, 1, and 1. So we have full red, we have no green, 0 green, we have full blue, and we have no transparency, or full alpha. And of course, red plus blue is the pink color. Now before I let you go, let me show you guys something. If you click on a number here, we get a more intuitive way of picking our values. So you don't have to guess values, you don't have to go to a different site to research values. You can just use the HSV color wheel here and see your colors and your values change in real time. Alright, so what did we learn in this video? Well, we learned the basics of how our environment is set up. A vertex shader was written for us, and that provides for us a canvas. Now we treat the canvas like a Cartesian coordinate plane, a 2D system, an X and Y system. The vertex shader also gives us a global variable called GL color, which we must set to a vector of 4 elements. We use the frag color variable to tell the GPU what color the pixel should be. In the next video, we'll go more in depth into what our fragment shader is actually doing. How do we display more than one color? Why can fragment shaders or shader programming in general be so difficult? Alright, I need you guys to do me a favor. In the comments section below, I need you to tell me how you found this video. Was it through the channel? Was it through a search term? Was it recommended from a friend or some sort of algorithm? Like, how are you people finding these videos? That answer is going to help me out a lot, guys. Thank you. And as always, you like, you comment, you share, you subscribe, thumbs up, vote up, whichever platform you're watching this on, all that good stuff. And I will see you guys in the next one.